live. Okay. All right, welcome, ladies and gentlemen, to another live stream. This is week 9 for our open Q&A. I see some of you guys have joined in or are here early, which is awesome because I was a little bit short on my questions for this week. I did not get my community chat out until later on Saturday night. So therefore, I was kind of a little worried because I got some questions. But boy, did you guys bring some questions. And I know there's been some extra ones that have been going on since I have kind of joined in. I apologize for just being a little late. I was going through a lot of questions for people that came up to the live stream early. And so I wasn't able to do a lot of the kind of checks with my lighting and my internet connection to get ready for the live stream. But I am ready to go ahead and work through some questions for you guys. And I know some of you guys that are just joining in, if you do have questions, feel free just to put them into the chat. I'll always try to do my best, depending on how long the questions that I have written down will take me. I try to like to work my way kind of backwards. But again, I always recommend that you guys go ahead and put those questions into the chat. So therefore you guys can help each other out as long as you're not spamming everybody in the chat. Nobody likes that. But I see a lot of you guys in there. I can't even say actually your names. It's going so fast, which is awesome. I'm just like amazed that so many of you have joined into the stream, and hopefully I can bring some value for you guys as we're going to cover some questions. So let's just go ahead and take a look at what questions I have from the start. And then if you guys do have some other questions coming up, then I'll be more than happy to see if we can address them after I'm done with these. So the first one we're just going to do is some composition or division as well as composition of two functions. Then I'm going to look into solving a square root, a inequality. Then I'm going to look into graphing a polynomial in factored form. Look into finding the derivative of our e to the square root of x. Then this one, we're going to look into converting this to vertex form. So we have two equations that we're going to write into vertex form. And then we also have some conic sections, which is going to be hyperbola and parabola. And for those of you that have been following along with my channel, you notice that we've just kind of finished our chapter on applications of trigonometry. So analytic geometry or conic sections is the chapter we will be getting into next. So we just finished up on the polar and parametric equations, as well as the law of sines, law of cosines, vectors, dot product, and a lot of word problems. So we just kind of finished that up there. And again, also, I'd like to welcome any of you guys that are new to my live stream. Basically, I go live every Sunday evening at this time, 9 p.m. Eastern Standard Time. And I take in questions from you guys that submit them on the community chat. So I make a post on community chat every Saturday, and therefore you guys can respond to questions that you would like me to cover. I am not a math genius, but I always will try to do my best. And again, really, guys, it comes down to, what can I cover rather quickly without doing a lot of effort. Therefore, I always like to kind of stay away from word problems just because it takes a while to present it onto the paper and sometimes also go through them. So I like to try to cover as many problems as quickly as I can, but also problems that I feel comfortable with my explanation. I don't want to confuse yourself or even confuse myself. Sometimes when you're going through a live stream, you're trying to do, a teaching, and there's so many things going on. You got this nice little chat that's like rolling things really, really quickly. And you see a super chat out of the corner of your eye. From Culo de Xavier, I do not understand what I can go over. Can you go over? I do not understand what you are asking for, but I just want to make sure. I think most of the super chats I always get. So, but I feel bad. There was a couple live streams back ago that I was having some trouble with my internet, so I wasn't being able to get to the live streams. But I really do appreciate you guys supporting me, and I did want to let you guys know that I did make a post. I did go live for a members only on Saturday this morning, and that's something that I'm going to kind of continue doing. Obviously, guys, this free open chat is going to continue on Sunday evenings. I really enjoy this. I like that it is open and free and busy. But if you also have a lot of questions and it is something that you're looking for a little bit more of a smaller chat, then the open Q&A for members only might be something you'd be interested in. You can go and check on the members. It's obviously that is more of a cost, so I totally get it if it's not. But again, guys, you can always add in from here. There's been a lot of people that have answered a lot of questions for you guys, which is awesome. So I really do appreciate you guys joining with me. Let's see, we get 10 minutes of me rambling on. So let's go ahead and get into some math. And come on, computer. Hi, Sailing Cam. Give you a nice little shout out. I see some questions. That is cool. May, very elegant. Thank you very much. Planos, Pack Rats, Angela, Justin C. What's going on? How are you guys? Angela, thank you so much for joining in. All right, guys, let's, I do see some other questions again, and awesome, guys. You know, as I mentioned, I'm going to kind of get into this math now. So I'm not going to be checking the chat. Obviously, sometimes I'll see a super chat, and hopefully I see all the super chats, just so I can at least give you guys a shout out. But then I'll kind of work through these, at least just focus doing the math and explanations. And then what I'll do is I will kind of revert back into the chat and kind of see what time we have available to answer any questions. So if you guys do have questions, please post them in the chat. If you have a way to respond or help somebody out, then please go ahead and do that. That is really appreciative that you guys can help each other out and getting some, math help even from myself or from anybody else that either has some prior experience or at least knows a good resource to kind of put you in there. All right, guys, let's go ahead and get started. So on the first one, the composition, so we have composition. So we have division of two functions as well as the composition. So I just kind of chose two functions here, f of x equals x squared minus x and g of x equals x minus 1. So when we have f of g of x, this is just one notation, but really what this just represents is the f of x function divided by the g of x function. Of course, can I, sorry, I just got another super chat. Can I go in my Pitos? I do not understand your question. But again, I don't know why I keep on getting questions on super chat that I'm not understanding, but if you want to reach out to me, LQ on Facebook or something else where I can kind of spend a little more time trying to figure out what you have, then just go ahead and reach out to me. But I do appreciate super chat, but I do apologize. I don't fully understand what it is you're asking for that question. So just reach out to me and I'll be more than happy to spend a little extra time for you because I do appreciate that super chat. All right, so I have f of x divided by g of x. So now I'm just going to replace here the f of x to be x squared minus x and then g of x to be x minus 1. Now, a lot of times, typically from here, we're looking into identifying either domain or to see if we can simplify this at all. And so in this case, we can factor out an x in the numerator, and therefore we would have an x minus 1 over an x minus 1. And therefore we could actually just simplify this over to x. Now, again, sometimes we want to identify the domain here. So the domain is going to be all real numbers except for 1. Even though 1 can be divided out, it's still going to be a whole in the function or in this division of two functions. So it's still going to be a restricted value. And I'm not sure if the student wanted me to cover going over the domain, but figure that's one thing that we at least cover in my class. The next example is the f of g of x, also known as the fog. So again, what basically that is saying is take the f of x function and plug in g of x. Okay, so that's really all it's asking. Just so like if you were to do f of 1 or if you were to do f of 2, you're going to plug in 2 in for x or 1 in for x. Well, now you're plugging in g of x into f of x. So that's going to look something like this. That's going to be g of x quantity squared minus g of x. Okay, now obviously we already know g of x is equal to x minus 1. So we can write x minus 1 squared minus x minus 1. And again, notice I'm using my parentheses because we have to make sure that we square the x minus 1. So again, that's x minus 1 times x minus 1. Right? I guess for the purposes of making sure students aren't making mistakes. Make sure you distribute that, okay? The negative, those are two common mistakes that we have here. So again, now I need to use FOIL here. So hopefully you are comfortable with doing the FOIL. Is that there is no restrictions. Like over here, 1 was not in the domain because 1 made the denominator equal to 0, which obviously once it gets simplified, that's no longer the case. But again, that represents a discontinuity, a whole. Discontinuity. Whereas here, there's no restriction. So my domain would have been all real numbers. Okay. The next example is solve an inequality. So again, we have a as our variable. So we're just going to isolate a by using the inverse operations. So the first thing we want to do is isolate the square root or the radical. So I'm going to subtract a 3 on both sides. And therefore I have 4a minus 5 is going to be less than or equal to 7. All right, now the next thing I need to do is I need to square both sides to get rid of the square root. All right, now we have to be careful when we square both sides. We're going to want to make sure now that we're going to be checking to make sure our answer is not going to include any extraneous solutions in this case. But for right now, I have 4a minus 5, so I'm just going to solve for 5 here. So I have 4a is going to be less than or equal to 54. Divide by 4, and you can say a is going to be less than or equal to, let's see, 54 divided by 2 is 27. So let's just write this as like 13.5. And I can't remember what else the student wanted. What else the student was looking for from there. But again, now it's just looking for all the values that are going to be less than 13.5. So if I can just go ahead and find my 13.5 and plus 3. And therefore, again, it's going to be a solid line. And now we're going to be basically looking for, if we're going to call this like a, right? A has to be less than or equal to 13.5. So therefore, that's going to be values here onto the left. And actually, I wanted to check something. I thought when I typed theirs in, let me check something real quick. Because I thought I was doing something on his 7. 4x minus 5. Oh my God, come on, seriously? Zoom. I just had my calculator because there's something I was looking at when I was looking at the graph. There's something issue with, so A is going to be less than an inequality. That's why it's shooting values to the right. Crap. I'm going to need some more time looking at that. I need to go back into my work. Well, I guess I'll just leave them. I'll come back. I just got to come back and look back at for that because that was something I worked through at the beginning. And I remember I was just going to go ahead and work through it. But now my brain is starting to get into that fog where I got to look into as far as understanding the solution. So I'll come back over to that problem in front of the chat. So the next example is, so the graph is g of x equals -1/2 x plus 5 times x minus 1 squared times x plus 2. And in this case, basically what we're going to do is identify the x-intercepts. So hopefully you remember that the x-intercepts is going to be when g of x is equal to 0. So I can set -1/2 times x plus 5. And again, also I mentioned, if you guys do have a question, if you guys saw what I'm missing up in this problem, like where my mistake or whatever else I was like my confusion, please feel free to let me know in the chat because I want to look back into there. But I was trying to see what was not making sense from that problem. And I know I wanted to look at the graph and kind of recognize this, why that is not working. So, but I do want to make sure I can provide you a better explanation. And if I'm not able to get to it, which probably tonight, because typically I want to make sure I can think through the problem and not be on the cuff when doing a live stream, which is not ideal, then I'll just make sure that I respond to you in the community post. All right. So in this next one, we have 0, -1/2 times x plus 5. Then x minus 2 or x minus 1, sorry. Quantity squared times x plus 2. All right. So basically now what we can do is go ahead and apply the zero product property. Now, one of the main issues is, we have all these products equal to 0, but one of the main issues here is we have the scalar. Now, again, the first thing we could do is we could multiply by a -2 on both sides, and that would get rid of the scalar. So Again, remember the scalar is not going to be an x-intercept. The only thing that each of these factors are going to produce our x-intercept. So I'm going to have an x plus 5 equals 0, x minus 1, quantity squared equals 0, and x plus 2 equals 0. All right, so therefore we have x equals negative 5. Here you take the square root of both sides, and you can see x is equal to 1. And then here x equals negative 1. I'm sorry, negative 2. Okay, so now let's just go ahead and plot those points. So I have a negative 1, 2, 3, 4, 5, negative 2, and a positive 1. All right, so those are going to be the zeros. The next thing we need to do is if you were to multiply this out, what would be the leading coefficient and the degree? So if I have negative 1/2, right? If I was to expand an x minus 1 squared, that would give me a x squared, right? That would be the highest power. I don't know what the rest of the well, I do, but let's pretend I don't know what the rest of the expansion would be. I know that the highest power, when I multiply x minus 1 times x minus 1, that's going to give me x squared. So this is going to produce an x squared. Dot, 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 dot. Well, if I multiply an x squared times another x, that'd be x cubed. Multiply by another x, that'd be x to the 4th. So I don't know what everything is going to be, but I know it's going to be an x to the 4th something, right? If you were to multiply this out, the highest power that you would get for your variable x would be to the 4th power. Now, I recognize that's an even power, but since my leading coefficient is negative, the leading coefficient test for the end behavior tells me my graph is going to go down and down, right? It's going to fall left and it's going to fall right. The other thing we want to do is look at the multiplicity. Now, again, the multiplicity is going to be the power of each of our zeros. When our multiplicity is odd, that tells us that the graph is going to cross at an x-intercept. And if our multiplicity is even, that tells us the graph is going to bounce. So at negative 5, you can see that's an odd multiplicity, so the graph crosses. At 1, the graph has a even multiplicity, so it's going to bounce. And then at negative 2, it is odd. So if I was going to kind of follow through here, well, that has to cross, that has to cross. And now you can see that it's going to bounce and then go back down. So the graph is going to look something like that. 4a minus 5 must be greater than or equal to 0. Yes, that is true. Maybe that was, and I think I even mentioned too, I don't even remember last time I was solving inequalities. So 4a minus 5 has to be greater than or equal to 0. So that's going to be 5. So a has to be greater than or equal to 5/4. That is true. Keep on coming with it, Dimitri, because I'm very interested to see what I went through on that or what else I'm missing. So a has to be greater than or equal to 5/4, which I think, hold on a second. Did I? Yeah, that was looking for my extraneous. There we go. Well, hold on a second. Come on. No. Where are you? Now, again, that was the graph that I was looking at, but that's going to be, if I'm going to be solving, that's going to be negative 7. It doesn't, well, as far as setting up my inequality, I know that a has to be, that's going to be greater than or equal to 5/4. I don't know why my chat keeps on getting disconnected. That's so annoying. To find extraneous solution, possibly. Well, I think my extraneous solution, which I didn't have my calculator, which I think I would have, if that was going to be 13.5, a is going to be greater, that would have been equaled. So that would have been less than 13.5. 5/4. I'll have to look back into there. And I sorry, baseball, it's been a while since I did my absolute value inequality. So I know I'm missing some important concepts on the problem that I need to make sure I address for you. And I'm just trying to recall them from my brain right now. Obviously, as far as like the domain, we know that this is going to be like under radical. We know that's going to be true. So I'm just trying to think of what else I might be giving as far as helping you out with the solving. All right, so let's go ahead and just continue on and then looking at this. So in the next example, I have y equals e to the square root of x. So notice that we have a function inside of a function, right? So we can think of this as two functions, f to e to the x and g of x as square root of x, okay? So technically we have the g of x function into the f of x function. So this is like the composition, right? So again, we have this composition of functions where we have one function plugged into another function. All right, so when we are doing the derivative for a function inside of the composition of functions, we're going to use what we call the chain rule. And the derivative then is now just going to be f prime of g of x times g prime of x. So the first thing we need to do is figure out f prime of x, which is the derivative of e to x, which is just going to be e to the x. And then we need to figure out the derivative of g to the x, which we could write as x to the 1/2. And again, the derivative using this power rule is going to be x to the 1/2 to minus 1/2 here. So which is another thing is writing 1 over 2 times x to the 1/2 power. So by now, go ahead and finding y prime. That is going to be my f prime of x, which is just going to be, so that's going to be e to the, again, of f prime is going to e to the square root of x. And that's going to be times 1/2 x to the 1/2 power. So therefore, that's going to equal now, if I write this as e to the square, let's go a little bit lower. E to the square root of x over 2 times x to the 1/2. And then again, you could write that as the square root of x again if you want to, or you could leave it as a rational power. All right, let's go into completing the square. So if you guys have been following my channel recently, I just did a video where I worked on 28 examples of completing the square, but the examples that I did not involve the fractions. So since those examples did not involve fractions, I'm going to go ahead and do these, but I'm not going to teach it the same way. I'm going to kind of go through the way of finding b first. And I'm sorry, using b divided by 2. So first thing you're going to want to do is I'm going to find b divided by 2 and square it. So in that case, that's going to be 5 divided by 2 squared, which in this case is 25 over 4. Ah, Amir, awesome. Thank you. Got some good questions. I'll go ahead and take a look at your work shortly. So therefore I have 25 over 4. And so now that is going to be the value that's going to complete my square. So I'm going to have x squared plus 5x plus a 25 over 4 plus 3. But again, remember, we just can't randomly add a 25 over 4 inside the parentheses. We need to make sure we also subtract a 25 over 4. All right, now this is going to be factorial into a binomial squared. One thing you can always do is it's going to be x plus or minus b divided by 2 quantity squared. So since this is obviously plus, we can just say that it's going to be whatever my b divided by 2 is. So therefore I can write this as a factored form of x plus 5/2 quantity squared. Now 3 I want to write in terms of fourths. So that's going to be plus a 12 fourths minus 25 fourths. So then to write this in vertex form, it would be plus a 5/2 squared, and therefore this would be a negative 13 fourths. All right, the next example here, y equals x squared plus 3/2 x minus 7. So again, first thing I'm going to do is take my b divided by 2 and square it. So b in this case is not that nice. Amir, I see your work. Thank you. I'll go ahead and take a look at it. I appreciate it. Oh, you're just making it neater. Okay, appreciate it. Thank you. So therefore I have a 3/2 divided by 2. Now again, dividing by 2 is the same thing as multiplying by 1/2, right? So therefore that's really going to be the same thing as 3/4 squared. which is going to be a 9/16. Okay, so that is going to be the value that's going to complete my square. So I'm going to take that value, x squared plus 3/2 plus a 9/16, and now that is a perfect square trinomial. And again, guys, you can always like check your work, right? Does 5/2 times 5/2 give me 25/4? Yes. Does 5/2 plus 5/2 give me 5? It does, right? But again, remember, we just can't add 9/16. We have to subtract 9/16 and then minus a 7. Okay, now again, what we're looking for here is our b. Oops, there's an x in there, isn't there? So again, this comes in the form of x plus b over 2. So y is equal to x plus, now b divided by 2 is going to be a 3/4 squared. All right, now let's make sure the 3/4 squared works, right? 3/4 plus 3/4 is 9/16. 3/4 plus 3/4 is going to be 6/4, which is going to reduce down to 3/2. And then now we need to rewrite this as -9 minus 16. So I'll put that over as 7. That's going to be 70. 70 plus 42. That's going to be 112. Oh, what am I doing? Let's just do 16. Am I doing my math right? I was going to multiply by 16, yeah. So let's just make sure, since I have a calculator, might as well just double check I'm doing my mental math correct. Yep, 112. Okay. So then y equals x plus 3/4 squared, and therefore that's going to be a -120/1/16. So now the one thing the other student also had a question on was as far as determining if these are maximums or minimums. And again, since my a is positive, you can see this graph is going to be opening up, both of these. So therefore, these are both going to be minimum values. Now, again, where does this minimum value occur at? Well, the minimum value occurs at what we call the vertex of the parabola. And the vertex, the reason why we like this form, this x minus h quantity squared plus k, is because the vertex occurs at h comma k. And you can see that these problems are not very nice because they're both with fractions, but you can see how they are h and k. All right, for next example, we have a hyperbola with crap. I think this is the center. And so the student was asking, can you write the equation? So first thing we want to do is we have the vertices, we have the asymptotes. I'm not 100% sure if I remember all the equations of the asymptotes. I'll try to do my best. Which one's b over a and which one's a over b. But for a hyperbola, though, let's see. First thing, actually, forget about that. Let's just go and plot the points that I have here. And because I'm not even sure we need this, actually. So we have the point 2, 1. And then we have the vertices are going to be 8. So 1, 2, 3, 4, 5, 6, 7, 8, 1. That's one vertice. And the other one is 1, 2, 3, 4, 5, 4. So 1, 2, 3, 4. Okay, that's the other vertice. So we have the center and we have the two vertices. Yeah, we are going to need that. Okay. Wait a minute. B over A over B. Okay, yeah. All right. So this is going to have a horizontal transverse axis. So if it has a horizontal transverse axis, that is going to be, let's just write this as, that means it's going to be x, what am I doing? X squared. Let's see if I can remember this formula here. Horizontal transverse axis, that means a squared should be under the x. So I should have x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. Please let me know if I have that incorrect. All right, so our center is going to be our h and our k. So that's going to be at 2, positive 1. Got that. A is going to represent the distance from our center to our vertice, which in this case is going to be 1, 2, 3, 4, 5, 6. So we can say A is equal to 6, h is equal to 2, and k is equal to 1. All right, so the only thing we need to do is figure out our b. Now again, they have an asymptote, and I believe the asymptote equation is going to be, for if it's horizontal, that means it should be B over A. So B over A is equal to 1/3. Well, we already know A is going to be 6. So B over 6 is equal to 1/3. And therefore, you could just do a little cross multiplication. You could say 3 B equals 6. So therefore, B is equal to 2. So therefore, now I have B is equal to 2. So again, if I recall, and again, I could have those swapped because it is different when it's vertical, but I believe the slope for the vertical is A over B. So the equation here is B plus or minus B over A times X minus H plus K. So I'm hoping that is the asymptote equation for a hyperbola for a horizontal transverse axis. And if it is, then I think I'm doing everything else correct. All right. So therefore, now let's just go ahead and plug everything in. So we have X minus H. So that'd be minus 2. Quantity squared all over A squared. So that's going to be 36 minus Y minus K minus 1 over 4 equals 1. And there you go. All right, guys, last but not least here. Oh, why did I do a parabola right there? That's kind of weird. Let's go and get to this last example here, or at least the last example that I have prepared. Another fractions doesn't seem very fun, but that's okay. Let's go and get to it. So here I have a parabola with a vertex of negative 5, 2. Crap, it doesn't say what this parabola is supposed to do, open to the right or to the left. I didn't copy down enough information. I don't think that's enough information actually for me to solve it. So, but either way, let's just set up where the parabola is. Okay. So first thing we want to do is negative 5, 2. So 1, 2, 3, 4, 5, up 2. Okay. So there's a parabola. Now the problem is we don't know where this parabola opens up to. We have an X and a Y coordinate. That's cool. But we're not sure if that parabola opens up, if it opens up to the right, to the left, or down. So actually, I believe, and I can go and scroll up, but I'm not going to waste the time. Let's just go ahead and set it up. Then I'll show you what to do, and just trying to assume here that it was supposed to be opening up. So even if I did do that, 5/3 to the right. No, okay, sorry. If it's going to 5/3 to the right and then negative 13/3 down, it probably either opens up to the right or it opens down. So if it opens up to the right, let me see. See if I remember these equations. You guys are bringing back my memory here on this spot. So that is going to be, let's see. So the equation here, we already did y equals ax squared plus bx plus c. We did y equals a times x minus h quantity squared plus k. And then we'd have y, let's see, that's going to be 4p times, so it'd be y plus k, no, minus k. Y minus k equals 4p come on. I'm trying to go off of my memory here, times x minus h quantity squared. That is correct. Yes. Okay. So that's going to be our formula. The y minus k equals 4p times x minus h. So therefore, if it opens down, then that's just going to be our equation. That just means p is going to be negative. So our goal here, so it either opens right or down. The student didn't specify, or I didn't read it. One of the two. But it has to open either down or to the right, right? Because this point, 5/3, is going to negative 3. It's going to be over here, right? So obviously it can't open up or to the left. So it has to be one of these two equations. So also it could be x minus h equals 4p times y minus k. Now, for both of these equations, we don't know what p is. So what you have here is you have your h and your k, and you have your x and y. And all you're simply going to do is plug in h and k, x and y, and then solve for p. So I don't know which equation you're going to do that for, but it's going to be for one of them. And you're going to have some fractions, so it doesn't look like it's going to be very, very nice. But that's exactly what you're going to do. It's just plug in x, y, and h and k for either one of these. So again, this is if it opens down, and this would be if it's going to open up to the right. But there you go from there. Hopefully that at least gets you set up to start, because I did already do a hyperbola problem, so I don't feel bad lifting you up from there. But otherwise, guys, thank you so much for hanging in. It is right side up. Okay, so it's going to open up to the right. Well, I'm kind of already at my point where I'm not going to be able to go through it. So therefore, though, I can at least get you started. So let's go ahead and plug in 5/3 minus a -5. Make sure you use parentheses. Equals 4 times p times y, which is a -13/3 minus k, 2. And that's going to be quantity squared. So what I would do is just get everything in terms of my 5/3. Let's just do, all right, fine. You're making me now do it. So let's see. Come on. So that's going to be a 15/3, right? That becomes a positive, and 5 can be rewritten as 15/3 equals 4p. You can go ahead and write this as a -13/3 minus 6/3 quantity squared. So this is a 20/3 equals 4p. Geez, I guess 19/3 quantity squared. Okay, so at this point, I will just go ahead and call it, because I'm not going to go through and work through all this craziness. But again, not all you're going to do is just square this, multiply it by 4, and divide it here on the other side, and then you're going to get some crazy number for p, but that's going to be your value p. So hopefully at least you got over the fraction portion of it. And yeah, that's just not a very nice problem. But either way, very much. Spam email, love you. Thank you. Alini, how are you doing? Any suggestions for trig resources? Podcast keep streaming. Thank you so much. Well, anyways, guys, I just want to let you know I am not at least official over at least with these questions. I might be able to get to some of your questions, but actually I just kind of feel like getting into the chat here just for the next couple 5 minutes. And maybe if you guys have some questions where I don't have to do any math and just maybe some tips like Alina's asking, then maybe I can help you out with those. That might be a little bit easier. I have a quiz tomorrow. I am not familiar with the pinches. I am so sorry. Oh, cool. Like, please again, reach out to me, send me whatever you guys have. But I do not have that for you. All right. Sunderland is asking something about the phase shift, and I'm not going to do the whole problem, but since he's asking something specifically, I will kind of like show it. So you need to understand when you're doing phase shifts for trigonometric functions, so actually really for any function, it needs to be in this form b times x minus c. So your phase shift in your problem is 4x plus 8 pi over 3. That is not in that form. So what you need to do is you need to factor out the 4. Now again, factoring out of 4 is really like the same thing as dividing out of 4, right? So if you divide both terms by 4, that's really like the same thing as multiplying by 1/4. So when you multiply 1/4 times 4x, you're going to just get x. And you multiply 1/4 times 8/3, you're going to get a 2 pi over 3. Okay, and again, you can always just check my work. 4 times x is 4x. 4 times 2 pi over 3 is 8 pi over 3. So again, just think of like factoring out. First of all, you have to understand how to factor out. You have to understand you have to factor that out. And then just think of like the factoring out as like dividing out that term. All right, Brick says, what do you do to get success in math class? I really think the success in math class can just come into a couple of things. One of the things actually I was thinking of, a lot of students have trouble, with mathematics. And I always get into this, I get in this conversation a lot with my students, as they always feel like some students, are better at math just because they are better at mathematics. And, it really kind of comes into, again, like, how are you learning? Like, what does it mean to really learn mathematics, right? If you kind of think about that, like, what exactly are you doing when you learn something? Well, when you're learning something new, all you're doing is taking your prior knowledge and you're connecting it with the newer knowledge. And sometimes people don't have the prior experience to make that connection. Sometimes people need to see that that new knowledge in a couple different forms to finally eventually make the connection. But I don't think there's anybody that obviously like is born with all this mathematical knowledge. There's people that are going to have more life experiences or more practice and are going to be able to connect that previous experiences to understand the information easier than others. But, so when students are struggling with math, rather than trying to think that somebody that does well in math just has a gift or is just natural at mathematics, I really, I really challenge my students to really kind of think about this is, try to think about how you can make these, connections. And one of the best things to make those connections is one, keep on asking questions, and two, to keep on practicing, because, we always kind of go through, it's like, you'll do this problem over and over, and then finally it like clicks. Right. Well, in reality, it's not like it just like clicks. It makes sense. But your brain is finally able to make that connection to previously what you're doing. So I think just, practicing, asking questions when you're confused or you're not understanding something, that's why it's very helpful to work with people or work with your teacher. And just to make sure that, any of those parts that get confusing, you can get those addressed. So hopefully that answers your question. That helps out. Just tell me how to solve with elimination. Yeah, just eliminate the variables. But basically, you're really just adding, right, or subtracting the two equations to get the coefficient of one of your variables to be 0. That's really like the end goal of it. Caleb, that's kind of a multiple question. I do not play any games. He does. All right. Okay. All right, let's go and see. I'm going to head back over to that original question because Amir spent some time put it in there. So I wanted to see what he wrote so I can just kind of follow. First one equals 7. Square both sides. Four equals 7, and you square both sides. That's 4, 5. Yeah, Amir. That was the same exact question I had. I had a 27.2, and I got the 13.5 as well. I guess to my point here. So it's an inequality though. So that's what I'll just have to go back to that. And I apologize for baseball. I'll have to go and see for you on that. You have to go and find the critical points of the inequality for the previous question. Yeah, you got to look at those extraneous solutions and go through this. Yeah, I'll go ahead and work through that problem, and I apologize. I'll just go and work through the problem. I just don't want to like make any or spend any more time just kind of going through it. But I'll go and work through it, and I will respond to you personally on that community chat with my response. I just need time to break out. But I did take on that question, and definitely it's something I can explain and go over. But I just kind of ran myself into one of those points where it's like, hey, you're going live and now you got to think on the spot. And it's a little bit easier, at least even when you're teaching, like in a classroom, it can be like, hey, hold on a second. Let me just like clear my brain a little bit. But you're live streaming. So, but thank you guys for pointing in the chat. I will go back once I'm done with the live stream. I'll just kind of go back through there. I think it'll just be a little bit easier for me to like kind of clear my brain for that. All right. Let's just see any more questions before I kind of get off. When you go over graphing radicals, what do you do with the number before the square root? So just to remember that when you're graphing really any function, if I have y equals f of x, well, remember when you're graphing y equals a, times f of x, meaning a number in front of that function, it's multiplying, that's going to be vertically stretching or compressing the graph. When a is going to be larger than 1, that's going to be a vertical stretch of the graph. When a is less than 1, that's going to be a vertical compression of the graph. So if you have the function, y equals, or I don't know why I'm giving the function, but either way, if you have y equals 1/2 or square root of x, like that's just going to be the square function with no stretch or compression, right? But if you go ahead and put this, like 10 square root of x, well, now what's going to happen? Let's just kind of show you, like, here's this graph. Now, if you put like a 10 in front of there, what that's going to do is that's going to vertically stretch the graph, right? And if you put like y equals 1/10 square root of x, then that's going to be vertical compression of the graph. It's going to look something like that. So that's all that number in front is going to be doing, is stretching, vertically stretching or compressing the graph. Darius says, hi, I'm new. Can I do an ambiguous case of a triangle? No, I'm not going to do an ambiguous case right now, just because my live stream is basically over as far as doing multiple math problems. However, if you do look at my recent uploads on my channel, I did do a full lesson on the law of sines, where therefore you can see, I think I went through 2 ambiguous case examples. They take a while. So obviously you can just kind of go through, it's a full lesson, so it's a long video. But you can just kind of go through, and then, which also another thing I want to let you guys know of, which I forgot to mention at the beginning of the live stream, is that I am now actually going back through my live streams and adding some timestamps. It's not going to be ready now for at least a couple months, but if you do ever come across one of my older live streams and you're looking for a certain question, my goal is to start putting the different types of questions, because you can see like everything I covered here is a lot of like stuff like all over the place. So what you'll be able to see is I'll be able to have a timestamp. So therefore, if you look in the description, you see something in particular that you're interested in, you can just go directly to that point. So that is something that is coming down the pipeline. All right. Thank you, Alexander. I appreciate the kind words. Hair reveal at 5K. Maybe, Andrew. Maybe. Go over how to graph points when slope is given already. I'm not really sure what you mean, how to graph points. I mean, basically, when you want to graph in slope-intercept form, the first thing you're going to want to do is find the y-intercept and then use the slope, or use the slope triangle, which is the change in y over the change of x, to go ahead and find different points in positive and negatives. So that's a very good question. Why is cosine of negative x equal to cosine of x? That's something I can just explain rather quickly without doing too much math. Crap. Well, I'll just do it right here. I don't want to create a new sheet. So the reason, well, it's not really the reason why, but here's the cosine graph, right? What I want you to understand is this graph is reflective about the y-axis, right? So it's even, and any even function has the characteristics f of negative x equals f of x. That is for all even functions. And even if you look at the unit circle, let's just go to, I don't know, pi over 4. So at pi over 4, we have square root of 2 over 2, comma square root of 2 over 2. At negative pi over 4, we have square root of 2 over 2, comma negative square root of 2 over 2. So you can see, you can see that my x coordinate is the same for positive pi over 4 as well as for negative pi over 4. And again, that like works over here. Like here's pi over 4 and here's negative pi over 4. So hopefully that is just a quick little description where you can see why that works. All right, guys, I see that some levels have now heightened between each other. And I see that I'm up to the number 10. So I think this is the perfect time for me to sign off for tonight. I hope you guys have an excellent week ahead. I know exams are coming up. So I have some more to talk about for you guys on that. But at this point, I think you guys can After this point, I think I'll go ahead and sign off and wish you guys the best of week. And I'll see you guys here next week for an open Q&A. And again, if you have those questions, please make sure you go ahead and ask those questions on the community chat, and I'll do my best to answer them, or at least try to either answer them on the stream or answer them inside of that chat. All right, guys, you have a great night and week, and I will see you next week. Cheers.